Okay, this video explains about the sketching of a EMF versus time variation graph for a movement of an AC generator. As what we can see on the right hand side here is the different position of the coil given at a 0 degree. Okay, in this position here, the coil is indeed in a horizontal direction. At a 90, the coil rotates clockwise towards 90-degree position, and then moving into a horizontal position, followed by again vertical and back to where it starts to make one complete circle or one complete rotation here. So by using this concept here, let's explain on the first position at a 0 degree. At a 0 degree here, imagine the magnetic field is acting horizontally towards right as given in the diagram. And for this position of a horizontal position of a plane, the normal of the plane is acting vertically upwards. Therefore, the angle it makes between the normal of the plane and the magnetic field will be equals to 90 degrees. So, to find the flux at any point, the formula that we will be using is equals to BA cos theta. So at 0 degree position here, the flux now is equals to BA. Take note, the cos theta that they are referring here is the angle between the normal of the plane and the magnetic field strength. In this case, it is equals to 90 degree, and therefore cos 90 will give us a 0 value. Therefore, the flux at this point going to be 0, or this exactly forms a minimum flux. Okay, and as the coil rotates to 90 degrees, let's look what happens at a 90 degree. Before this, for the 0 degree, we know the flux is minimum, so I'm going to plot a minimum value at this point here. Next, at a 90 degrees, again the same formula, flux going to be equals to BA cos theta, where this time here, the cos, if you look here, the normal of the plane is indeed acting on a horizontal direction too, and therefore the angle between the normal and the B field here are equals to this time here is equals to 90 degree. Okay, sorry, they are parallel. That means they are equals to 0 degree. If you look here, the direction of the normal and the B field are parallel to each other. So therefore the angle equals to 0. So the flux this time going to be equals to BA cos 0, which going to give us a maximum flux because cos 0 equals to 1. So the flux here is equals to BA only, which gives us a maximum flux. So therefore, for 90 degrees, you're going to form a maximum flux. Okay. What happens at 180 degree? At 180 degree, the coil has rotated 180. That means previously at a 0 degree, the normal was pointing upwards. As it rotates 100 degree, 80 degree, now the normal is directing downwards. Therefore, again the same formula. Flux is equals to BA cos theta. And this time, the angle here going to be again 90 degrees by acting on the opposite direction. Flux equals to BA cos 90. And therefore, you're going to get a 0 flux again, minimum flux at this point. So let's label the second point, which is going to be equal, third point here, which is going to be equal to minimum flux. At a 270 degree now, the normal is now acting towards left, whereas the magnetic field strength is acting towards right hand side. So again, flux is going to be equals to BA cos theta, and the theta now is equals to 0 degree. Look at here, the B field and the normal, the B and the normal are parallel to each other. However, now they are acting on an opposite direction. So therefore, it's still going to form BA cos 0 because the angle between them are 0 degree. But however, this time the normal and the B are acting on the opposite direction. Therefore, the flux is going to be maximum but acting on the opposite direction of the previous one. The opposite direction here can be shown by using a negative sign. Negative shows the opposite direction. Therefore, you're going to have a next maximum flux formed on the negative direction. Then again 360 degrees. I'm not going to show the formula. At a 360 degrees here, the normal will be acting back upwards. Exactly where does it start? And the angle between the normal and the B are 90 degrees, means 90 degrees cos 90 0, so flux becomes 0 again. So the graph that you get for flux over time is as what I have drawn here, where it's going to be looking as a sine graph. But remember, this is not a fixed value. Okay, do not memorize the graph here, because it always changes according to the actual or the initial position of the coil. Okay, anyway, since you have plotted flux over time, let's look on next graph here, which is going to be change of flux over time. So what is this change in flux over time here? So now, from the graph, it is very flux over time. The next graph that we are looking here is a change in a flux over time, which means the gradient of the first graph is equal to the change of a flux over time. So at a point number 1, or at a 0 degree, if you have a look here, it exactly has the most steeper point of a gradient. Therefore, the gradient is a maximum gradient and is a positive gradient. So therefore, the change of flux of time over time at this point is going to be maximum. Next, at 90 degrees, if you look on a gradient value here, the gradient is indeed equal 0 because it's a horizontal line here. The gradient is exactly horizontal, means the gradient is 0, means the change of flux is going to be also 0. Next, at point of 180, we're going to have the most steeper point here, but this time the steepness is directing downwards, means it's a negative maximum gradient. At a 270, it is again a straight line of a gradient, means 0 gradient, and at 360, it's a steeper line at a 360 and maximum gradient pointing upwards, positive gradient. Therefore, the graph of flux over time that we're going to get is as what I've shown you here. Okay, next, let's look the formula for EMF itself. EMF is indeed equal to the negative of rate of change of flux over change in the time. This is the formula here. Okay, why there's a negative sign in front here? This negative sign is indeed showing us that the current induced will always travel in the opposite direction. This is very much related to the Lenz's law that we have learned. The current induced will always travel in a direction such that to oppose the change that causing it. The graph, the second graph that we have drawn is about the change of flux over time. But however, what need to be considered here is the negative value that we have in front here. So therefore, the negative will indeed inverse the second graph that you have plotted. The maximum rate of change of flux here now become a maximum but on a negative direction. The 0 still remain as a 0. Negative maximum become a positive maximum. 0. Maximum change becomes a negative maximum. Therefore, the graph that we will be plotting here will look as what I have here. It's opposite of the graph that you have drawn. This is how the graph of EMF versus time will look like if the initial position of the coil is given as in this example.